Hi, my name is David Lucas, and I am a professional naturalist who works in Yosemite National Park. I'm going to tell you a story about Yosemite, but first, let's start in a rather unexpected place, China's capital city of Beijing, a city which is famous and you might even say infamous for its choking air pollution. Well, it turns out that one of the major components of Beijing's dirty air is sand and dust that blows off the Gobi Desert. These choking particles are lifted off the desert in massive storms that disperse sand and dust locally, and they're also captured in high-level jet streams. So how does this connect the Gobi Desert to Yosemite? Well, scientists have long suspected that water droplets in clouds form around dust particles. And in fact, when scientists analyzed rainfall in the High Sierra, they found that many water droplets in clouds contained dust from the Gobi Desert. This would mean that the spectacular waterfalls and glacially carved canyons that make Yosemite National Park so famous were all created by clouds and rain generated by dust storms from the Gobi Desert. That's pretty cool, right? Ah, but only if the story were this simple, because scientists found something else that they did not expect. Before I tell you what they discovered, let's peek at the mechanisms of rainfall. We know that clouds are formed of water droplets, and these droplets are very tiny, scarcely wider than a red blood cell in your body. In the Sierra Nevada, where winds blow from the west to the east, clouds form as air is lifted over the mountain crest and cools. What people don't realize, however, is that an individual water droplet in one of these clouds is in existence for less than an hour before it gets blown over the crest and evaporates. So how do these tiny ephemeral droplets fall as rain then? You might imagine that droplets simply collide and merge with each other until they are large enough to fall as rain. But this is not what happens. What happens is that each droplet of water must first freeze into ice, and then, if conditions are just right, that tiny ice crystal grows into an increasingly complex hexagonal framework that eventually becomes so large and heavy that it falls out of the sky as a frozen pellet that melts into a raindrop as it plummets towards Earth. And if you think about it, this makes sense. Water droplets don't just fall out of clouds by themselves, or else it would always be raining every time a cloud passes overhead. It turns out that something has to trigger the transformation that changes water droplets into ice pellets that can then fall out of clouds. And this trigger is what scientists unexpectedly discovered in the Sierra Nevada. The key piece of the story here is that ice cannot build complex hexagonal frameworks on the irregular surface of a random dust particle. In fact, ice crystals need a very specific and predictable molecular surface to trigger their formation, and that exact molecular shape is coded by a protein gene on the outer shell of a single species of bacteria. It turns out that this bacteria, Pseudomonas syringae, triggers the formation of 80% of the ice crystals that fall out of clouds as rain. So why would Pseudomonas syringae evolve this remarkable ability to produce ice? Well, it turns out that this extremely abundant bacteria is found on the surfaces of leaves all over the world. It lives on leaves because it feeds exclusively on the yummy contents of leaf cells. But leaf cells are protected by tough cell membranes. So the bacteria have evolved an ability to form ice crystals that then work like jackhammers to pry open cell membranes and release their contents as the cells freeze. If you've ever put a bottle of water in your freezer and had it burst open as it froze, you can imagine how ice could pop open cell walls as well. And on hot summer days, these same bacteria get lifted off the surfaces of leaves by evaporation and are carried up into the upper atmosphere, where they would be trapped forever, except that they use the same ice formation technique to get back to Earth in the form of rainfall. Scientists have even begun to suspect that patterns of vegetation on the Earth's surface are largely driven by the presence of these bacteria creating local rainstorms. It seems to be a kind of evolutionary handshake. Plants agree to feed the bacteria, and in exchange, the bacteria delivers rainfall that keeps the plants alive. Now, if you're disappointed that we kind of strayed from the initial connection that we forged between the Gobi Desert and Yosemite National Park, don't worry, because just last month, scientists discovered another amazing link. Yosemite is world famous for two things: for its outstanding granite landscape and for its giant sequoia trees. But in an odd twist of fate, these two features don't really fit together. Granite, for all of its stunning beauty, lacks phosphorus, which is essential for plant growth, especially for the growth of large trees like giant sequoias. Scientists have been long mystified about the source of phosphorus in the Sierra Nevada. If it doesn't come from local granite, then where is it coming from? And guess what? It turns out that 50% of the dust that settles in the Sierra Nevada is phosphorus-rich dust from the Gobi Desert. Therefore, the giant trees of the Sierra Nevada are possible only because of the Gobi Desert. In more ways than we could have imagined, Yosemite National Park has been shaped and created by a region halfway around the world. The more we learn, the more we realize that the world is truly an amazing place.